I did question 6 from the 2006 test, and it asks a photon with a wavelength of 1.5 times 10 to the negative 8th meter is emitted from an ultraviolet source into a vacuum. Part A asks calculate the energy of the photon. I used velocity equals frequency times wavelength, and energy equals Planck's constant times frequency. Used algebra to get frequency equals velocity over wavelength. And I substituted that in for frequency and got energy equals Planck's constant times velocity over wavelength, and that's just hc, because the velocity is the speed of light. And substituted those in as hc from the green sheet and put that over wavelength from the problem, and I got 1.33 times 10 to the negative 17th joules as the answer. Then part B asks calculate the de Broglie wavelength of an electron with the kinetic energy equal to the energy of the photon, and kinetic energy equals 1/2 mv squared, and I set that 1/2 mv squared equal to the energy we found in part A. Then I plugged in the mass of an electron for m right here, and just used algebra to find v, or to find this velocity. Then I used wavelength equals Planck's constant over momentum. I split momentum into mass times velocity and plugged in the mass of an electron and the speed we found in the first part of B, and divided Planck's constant by both of those to get 1.35 times 10 to the negative 10th meter. And then part C asks describe an experiment that illustrates the properties of this electron, and I said you could by shining a stream of electrons through a double slit, you could find the wavelength using the equation x equals m lambda, or m wavelength times the distance from the screen to the slits, divided by the distance between the slits, where x is the distance to the closest maxima if m equals 1. So that's what I did. It's pretty much alright. Yeah, it's alright. Checked it. See ya.